So hello everyone, and thank you for your time and for being here. My name is Piispanen. I'm a doctoral candidate at the Aalto University School of Science, and I'm here presenting our paper, The History of Quantum Games. So my background and education comes from theoretical physics and the foundations of quantum mechanics. But through curiosity, I've wandered into the intersection of quantum physics, games, and art. And instead of our game theoretic approaches, we are discussing here games that one way or another relate to quantum physics. So we may start by noting that playing games is part of human nature, and the history of games and play extends far in the history of human beings. But as we want to concentrate on quantum physics-related games, we do not need to go that far, as the theory of quantum physics is a little over 100 years old. So quantum physics is the theory that describes the behavior of the particles, little atoms, and phenomena at the subatomic scale. And these phenomena are so that we don't observe in our everyday lives. And in order to learn about the theory, mathematical formalism and rigor is required, at least up to some simple linear algebra before diving deeper. And the theory is also overly mystified through the use of terms like spooky action at a distance, or the way movies and New Age conmen use the terms that are related to theory for the purpose of their agenda. Also, to many, the relevance of quantum physics to the everyday lives is unclear, which might lead then to the conclusion that quantum physics is irrelevant. But we wouldn't have lasers, transistors, MRIs, or working navigation systems without quantum physical phenomena. And studying and learning about these phenomena, it has benefited from simulations, so games are also introduced as an appropriate way to bring something more tangible about the theory. But not all quantum games are serious games. We'll start by looking at the games from 80s, when the earliest quantum physics related game in our data was created. This here is Atari's Quantum, where you use an optical tracking ball to capture different types of particles from the screen. And here we have a screenshot from Quantum Soccer by Craig Hagan. There's a probability distribution of a certain type of a quantum physical system at play there, pushing the ball. And here we have Marie Curie playing a virtual reality version of Quiz, a citizen science game that I was also part of developing. And the number of games that relate to quantum physics and quantum technology has greatly increased in the last few years, 10 years or so. And because interest has grown around their academic use and educational use. But the vast majority of quantum games have been created through quantum game jam events and hackathons. And here we have a graph of the number of quantum physics related games from the year 1982 to 2022. And we see two peaks. The first one is in 2015, and out of the 32 quantum games developed that year, 28 were developed at the global edition of Quantum Game Jam. The other peak is 2 years after the release of Qiskit. It's an open source SDK for working with quantum computers and simulations. And in 2019, there were multiple hackathons and game jams with that theme that connected to the use of Qiskit and to combine that with games. So I've collected this list of quantum physics related games since 2017 and noticed that many of them don't have a serious purpose behind them. And looking at this list, it also gave the question of how are these games then characterized? And they clearly had at least 3 distinctive ways they referenced the theory of quantum physics. And we call these the dimensions of quantum games: perceivable dimension of quantum physics, dimension of scientific purposes, and the dimension of quantum technologies. So in a preprint, my colleagues from IBM Research and Aalto University, we provided a formal definition to quantum games through these dimensions. So quantum games refer to video games, analog games, and other variants of games that reference the theory of quantum physics, quantum technologies, quantum computing. Through the perceivable means, they connect to quantum physics through a scientific purpose or use quantum technologies. So we'll now see what these dimensions of quantum games mean by looking at some example games. And we'll start by the perceivable aspects of quantum physics in these games. And we search these aspects through the game itself, the gameplay, intro, info menu, or anything related or the surrounding material, and anything that's perceived in that. So they may be visual aspects, thematic relations, storytelling, or actions in the game. The game may, for example, have some visual aspects in it. These aspects may be thematic references, like depicting quantum hardware, quantum computing formalism, like in this card game, Q cards here. It may have like particles, lasers, or Schrödinger cats, like here in what's in the box from 2015. Or the visuals may have a simulation of a quantum physical system connected to them. So the visual elements might even stem directly from this numerical simulation or quantum computers. And here in this game, for example, the shape of the wave is depicted by a probability distribution of a so-called Bose-Einstein condensate. The perceivable aspect may also be in the storytelling. During development of Quantum Break, a quantum physicist was consulted so that they could create a storyline and actions in the game that deeply connect to quantum physics. Storyline and connections can be also created through sourcing quantum hardware, like in the clay prototype proposed. And another perceivable way, like I said, are the actions that reference quantum physics in the game. So like in this game, Entanglement Hypermaze, you can switch between two superposed characters, and also stepping on a tile locks its shape. So it's a reference to quantum measurement. And then we have the scientific purposes of quantum games as the second aspect. So these may be educational or training purposes or citizen science purposes, for example. Quantum Race, exhibited at a festival, explains complex science concepts to school children. And similarly, engaging a younger audience is done by QCraft, released in 2013 for the game Minecraft as an edition. And rather than simulating quantum physics, the mod presents like analogies for the player and demonstrates how quantum behavior varies. One of my favorite examples is the quantum flytrap here. Please Google it and go and play it. It simulates a quantum optics laboratory equipment setting, and by playing it, you'll learn kind of like the logic behind what happens at quantum optics laboratory. In 2018, IBM Research gave this board game, and it's also introducing like basic concepts of quantum computing. And similarly, they have Hello Quantum game you can download on your phone and learn some basic logic behind like quantum computing. For outreach, we've also had these interactive art installations that have gamified aspects in them, like Quantum Garden and Quantum Playground, that depict superposition as a colorful wave-like visualization. And then there's the purpose of citizen science. Games that are centered around the problem of optimizing quantum state transfer processes within the framework of quantum optimal control, like Quiz. For example, you're in a laboratory, it's a magical laboratory where you try to control a liquid in flasks. And then a very similar game is Quantum Moves 2, but it was more professionally developed further and researched a lot more. And then we have the games that connect to quantum technologies and are played on quantum computers, so quantum computer games. Some of the early devices that could be considered as quantum computers have been publicly accessible for researchers and other quantum enthusiasts via IBM's Q-Experience since 2016. And they have a graphical interface to it, and also introduced Qiskit, the SDK, for this purpose. So these games are either like games on quantum computers, or they're using like simulations of these quantum technologies and quantum hardware, because for accessing the computers, you either have to own a quantum computer of your own, or you have to wait in line to get your turn to use it. But the first computer on a quantum computer was developed by James Wooden in 2017. It's called Cat Box Scissors. And the game was developed using the Python computer language as a demonstration for the first available quantum devices through this very simple command line interface. But the game allows you to play against a quantum computer, and the moves are affected by quantum sourced randomness that was really present, especially in the early hardware. And this leads to noise in the opponent's moves, and offers a possibility for a winning tactic over the quantum computer. Here's another example called Quantum Solitaire, which simulates a quantum hardware and provides an intuitive feel of what quantum entanglement can do. So the purposes behind quantum games may not be serious, but we may find many types of uses for the other types of games. So, for example, to bring awareness with any perceivable aspects in the game. They may general interest towards quantum physics to learn more, or they may be used to break biases. They can also be used for outreach, which is also kind of like a dimension of scientific purposes, or talent acquisition. They can be used as pedagogical tools. Usually there needs to be a perceivable dimension then, of course, but it has a strong dimension of scientific purpose then. Or citizen science, which then may also be used for testing the capabilities of quantum computers. So as a conclusion, the development of quantum games has received a lot of interest from research groups involved in quantum technology development, quantum computing experts, and quantum physics educators, mostly for serious game purposes. But since the formation of quantum game jams, artists and game developers who have had no previous background in quantum physics theory have played a significant role in the expansion of quantum games. So not all quantum games have a serious or applied purpose, and quantum physics also inspires entertainment games, both commercially as well as through smaller projects. But it is important to view the history of quantum games so that their purpose and potential can be better understood when utilized in education or training. And as another important function, attractive quantum games and interactive quantum art will play a vital role in further popularizing the appeal of quantum physics and quantum technologies towards the general public. And with this, thank you for your short time. And I invite any questions either through this event platform or by contacting me later. Thank you.